Great, so now we're actually moving into section 1.8. We're going to take a look at right triangles. So here's a right triangle. You can draw the right triangle any way that you want to. Let's say you wanted it to be this way. That's fine. It doesn't matter to me. But what you do need to do is you do need to label this in on the sides in this order. So the A and B should be the legs of the triangle, and C should be the hypotenuse. And the reason that we're going to do that is that we eventually could be using the Pythagorean theorem in a right triangle situation, which then we want A and B to be the side lengths of the legs, and we want C to be the hypotenuse. And so that's going to be one of the important things that we use in this section is A squared plus B squared equals C squared. Okay, the Pythagorean theorem. Another piece of information that we need to know is that the angles that are associated with those sides are on the opposites of each other. So I have an A over here opposite the side A. I have capital B over here, angle B opposite side B, and I have angle C opposite side C. Angle C then ultimately every time becomes the right angle because it is opposite the hypotenuse. That the 90 degrees is going to be the longest side of this triangle. Inside this triangle, I have 180 degrees. So if I take angle A plus, angle B plus angle B, that gives me plus angle C, that gives me 180 degrees. Okay, so we're talking in degrees again. We take a step back from radians and start talking about some things that we actually know about or are a little bit more comfortable with in these 180 degrees. So angle A plus angle B plus angle C is equal to 180 degrees. Those are all important things that we're going to need to know in order to do these problems. So here's the assignment. If you are missing any quizzes, that's the assignment that you're going to be wanting to look at. That's actually going to be for 1.8b. 1.8a is going to be a worksheet that I'm going to show you in a minute here. But here's how we go about solving these problems. So the problem says solve the following triangle. That means that I need to find all 6 parts of it. And it gives me a couple of them. It gives me the 34 degrees for A. It gives me that B, side B is equal to 5. And when I construct the triangle, I still have that C is equal to 90 degrees. We just talked about how that's always going to be the 90 degree angle. Well, that means that if I take the 180 degrees that are in the triangle and I subtract the 34 degrees and I subtract the 90 degrees, I'm going to end up with angle B. So angle B is equal to this, 180 minus 34 minus 90, which is going to give us an angle of 56 degrees. So angle B is 56 degrees. And now, at some point here, I need to find out the other sides. Well, in order to find out the other sides, I have to use some trig. And so I have a lot of information that I could use in here. I have this 56 degree angle. I have a 34 degree angle. I have a 90 degree angle, but we don't necessarily want to go and use that one because sometimes at that 90 degree angle, if we're doing tangents, we end up with undefined things in some situations. So we want to make sure that we try to stay clear of using the 90 degree angle. But any other of the other 2 angles we know are going to be correct because we used a good math method in order to find them. But we want to use a trig function. Well, I have this 56 degrees, and I have the side that's opposite of that. So I know that if I do the sine of 56, that's going to be equal to the opposite, which is 5 over, I can pick any one of the hypotenuse here. So I've got sine of 56 equals 5 over c. I could choose that one. And you could go ahead and solve that one if you wanted to. I have an adjacent angle to 34, so I could use the cosine of 34 is equal to 5 over c. Okay, so I could use that as well. There's a tangent angle in here. if I go the, let's say the tangent of 34 is equal to the opposite, which is a, over the adjacent, which is 5. Okay, and there's lots of different choices that I have in there. And ultimately, you just need to choose one and then solve the equation. That's the part that we've done before. I'm going to choose this one just because it's the last one that we chose or we had up here. And when I multiply that out, the tangent of 34 times 5, making sure that my calculator is in degrees so that I end up with a proper A angle here. I end up with A is equal to 3.37. And we're going to round everything to hundredths here. So I get A is equal to 3.37. Now I've rounded that 3.37, so because I've rounded it, I'm not going to get a good number if I use the Pythagorean theorem here. 3.37, I rounded that, has a decimal version. I continued on that 2542584, but I rounded it. So I don't want to use the Pythagorean theorem here because I'm going to end up with a rounded C. And it's going to be, I'm going to round that answer for C to begin with. And so I rounded it to start and I rounded it at the end. Makes it a little bit less exact than what I actually want here. And so I'm going to use one of my other trig functions to find that C. We talked about a couple other ones here. We said that we had sine of 56 was equal to 5 over C. That was one of the other ones that we had up here. So I'm going to multiply by C on both sides. So I get C times sine of 56 equals 5. I have to divide by sine of 56. So I get C is equal to, on the left-hand side, 5 divided by the sine of 56 gives me 6.03 for my C value. Okay, so I end up finding all 6 portions of this triangle. Well, we'll go through a couple more here, and but a little bit faster. I'll draw in the triangle and the other information, and then we'll run through the steps for it here in a second. Okay, so here's example 2 with all the information plugged in that they gave me in red, and then the information that I can easily find by knowing that inside the triangle it's 180 degrees, subtracting the right angle, and then subtracting the angle that they gave me. I get that A is actually equal to 36 degrees. Now I have C is equal to 17.4, so in this problem I have one angle, I have the 54, and so ultimately again it doesn't matter how you go about this, which trig function you use. I'm going to use sine of 54. Sine of 54 is the opposite, which is B over the hypotenuse, which is 17.4. Multiply by 17.4 on both sides. That's going to give me B. When I do 17.4 times the sine of 54, I end up with 14.08. Please round properly to the hundredths place. So I get B is equal to 14.08, whatever measurement this is for that side length. And then I need to find A. Again, I do have the option of using the Pythagorean theorem, but because I rounded that B value, I end up with a value that is rounded at the beginning, rounded at the end, and so it's not quite as exact as I want. Where as opposed to just using the trig function and then rounding at the end, it's a little bit more exact. It's not completely exact, but it's a little bit closer. So in this case, I want to go and I have the adjacent side to this this 54 degrees is A, so I'm going to use the cosine of 54 is equal to the adjacent over 17.4, which they gave me. So I have 17.4 times cosine of 54. Okay, gives me the A value, which is 10.23. Okay, so we went through and solved example 2. Now on to example. So when I go through in example 3, this is the reason why we're doing this section. what makes it a little bit different than what we did before. They give me two sides. Plus I have the C angle that's an included angle here that's 90 degrees, because C is always going to be that 90-degree angle. They didn't give me any other information, so I can't find the angles by just taking 180 minus them. I have two values for my sides now, so I am comfortable using the Pythagorean theorem in order to find out what that third side is. Okay, so I end up with 6.3 squared plus 9.2 squared. And then I'm going to add those together, so I get 124.33 is equal to c squared. I have to take the square root of both sides here. And I get 11.15 is equal to c. So I get c is 11.15. Okay, so that finds the third side there. Now I need to find the angles in this. In order to find the angles, I'm going to need to use a trig function. So let's do the sine of A, angle A. Why that turned blue, I'm not 100% sure. So sine of A is equal to the opposite, which is 6.3 over the hypotenuse, which is 11.15. Now, I can use that. I rounded the 11.15, and that causes my answer again to be rounded at the beginning and then rounded at the end. If you're looking at this, we're going to continue looking at the fact that I'm given two pieces of information here, and the two pieces of information are in terms of the A value, they're actually tangent to A, because I've got the opposite and the adjacent. So I've got the opposite, which is 6.3, and the adjacent, which is 9.2. And I can go through and solve this using an inverse function. So in this particular case, it's a little bit different situation. I can't just do the tangent of a number. I can't just solve it. So I have to actually get rid of the tangent to find out what A is equal to. And so the way that I get rid of a tangent is I take the inverse of it. So if I take the inverse of the tangent A, the inverses cancel each other out, and I get A on the left-hand side. Well, if I did that to the left, then I have to do that to the right as well. And that's where some of you have been wondering what the t to the -1 button right above the tangent button on your calculator does. This is what it does. So we want to use that button. So second tangent of 6.3 divided by 9.2, which gives us a 34.4 degree angle. So my A is actually 34.4. And again, we'll round to the hundredths. This would be 0.40 if you were rounding that way. Now again, at this point, you could use a trig function to find out what B is, but because we know that there's 180 degrees in the triangle, I now can use this to figure that last angle out. Angle B is equal to this. And so 180 minus 90 is 90. 90 minus 34.4 is going to give us 55.6 degrees. Now, if you actually use the trig function here, the trig function that would find us angle B would be, let's go tangent of angle B equals 9.2 over 6.3. And so I take the tangent inverse of both sides. Let me put my pen down here and move that over. So we end up with doing tangent inverse of that fraction flipped over. So 9.2 divided by 6.3 instead of 6.3 divided by 9.2. And I end up with 55.6 degrees that way as well when I round it. So it doesn't necessarily matter which one you use in this case, because ultimately the inside of that triangle has to be equal to 180 degrees. If you're using the tangent of this, and let's say this came out to be 55.7 because we rounded it to the tenths. Well, 55.7 plus 34.4 does not make that 90-degree angle to be added to 90 degrees to be 180 inside the triangle. So you have to be careful if you're using the trig function and you're rounding. Anytime that you're rounding, you have to be aware of the fact that these constraints are on here. Inside the triangle, it has to be 180. If it doesn't come out that way, then you have to retry it. So let's take a look at the last example here. All right, so in example 4, here's the triangle. We've got C is equal to 90 degrees. They gave us 2 sides. They didn't give us the third side. Okay, so all this information is in here. In order for us to figure out side A and B, or angle A and B and side B, we have to use the inverse trig functions and the Pythagorean theorem. So let's start with the Pythagorean theorem. We have 8.3 squared plus b squared is equal to 34.1 squared. When I solve that problem, I have 8.3, which is squared is 68.89, plus b squared equals 34.1 squared, which is 1,162.81. I'm going to take that and subtract the 68.89 from both sides, so I get b squared equals 1,093.92. Take the square root, and I actually end up with b being 33.07. So 33.07 is the b value. I'm going to try to find a. I have the opposite of a over here and the hypotenuse, so I'm going to do sine of a is equal to 8.3 over the hypotenuse of 34.1. This is where I want to use the inverse function to get rid of the sine. So I'm going to do sine inverse. So those are going to cancel out on the left-hand side, and I get a. On the right-hand side, I get sine inverse of this fraction. Don't turn the fraction into a decimal, 34.1. Don't turn the fraction into a decimal until the calculator does it. So I want to do inverse sine of 8.3 divided by 34.1. I actually leave those as a decimal, so then you get a better exact answer. So I get 14.09 degrees for angle A. Now at this point, I'm kind of stuck because if I use the trig function again, I would have to do cosine, and if I do the cosine value of that, I'm going to end up with a rounding situation where I rounded and so on. So then I have to change the angle to do sine of b equals the opposite, which is b over 34.1, and that really doesn't help me, so that's not actually what I wanted to do. Hold on one second. As I change that up, I actually want to look at, so I have angle A now, I have angle C. I just want to do 180 minus 90 minus 14.09. That's going to figure out what angle B is. So I end up 180 minus 90 is 90, minus 14.09 gives me 75.91. So I get 75.91 degrees for angle B. Go through and work the rest of the problems on the example problems. Some of them in there are word problems, and we'll do that on the next video. But what your quiz is actually going to be on is finding the missing sides and angles from this worksheet. So go through and we're only looking for, in this problem, we're only looking for what this angle is for the first 8 problems. And then we're only looking for the measure of whichever side is asked for in the problems down here. So I'm going through just doing one thing. That was the work that we had done before. When you get to the back here, it says to solve each triangle. That's the work that we're doing at the beginning of the video here, where we actually want to find each one of these parts. I want to find angle B, angle A, angle C, side A, side B, and side C. This is not something that you're probably going to be able to cram just on this sheet, so attach a second sheet with some work if you need more space than what's on here.